So now let us understand the next term in the chapter, that is electrostatic potential. To understand this, again I am going to consider the same configuration of charges. So this is some source of electric field, this is some charge configuration which is producing some electric field around it, and there is a test charge which I have placed at a point P. In the first chapter, to characterize this electric field, what did we define? To characterize the electric field, to characterize the strength of electric field, we defined something called electric field intensity. And how did we define it? It was defined as force per unit test charge. Yes, this was known as electric field intensity. So there, to characterize the electric field, we were using the force on the test charge. And when we divide it by the test charge, the dependence of electric field on the test charge, it disappears. For example, I want to make this part clear. Electric field due to a point charge, it was K Q upon R square. So where this Q charge, it is a source charge which is producing the electric field. So is there any dependence on test charge? No, because we use the force on the test charge for characterizing the electric field, but when we divide it by the test charge, dependence of electric field disappears from the test charge only. Okay, so this was done in the first chapter where we characterized the electric field with the help of electric field intensity, which is measurable in terms of force. Now, the previous topic we discussed, that was about potential energy, electrostatic potential energy, which was defined as in terms of work done in moving the charge by the external force in electric field. You tell me one thing, if this electric field is much stronger and I have to move this charge from this point P to this point Q, if this field is strong, I have to do more work, and if this field is weak, I have to do less amount of work. So tell me one thing, can I characterize this electric field of this charge configuration in terms of work? Answer is yes. So what is the difference? There we were characterizing the field in terms of force, which is a vector quantity, and now I want to characterize this electric field in terms of work, which is a scalar quantity. So how do we characterize this electric field in terms of work? The physical quantity we use it for this, that is the electrostatic potential. Okay, so that means to characterize the electric field, one more way is there, and that is with the help of this electrostatic potential, which will be in terms of what? In terms of work done. What is the difference now? So here you characterize the electric field with the help of a vector quantity, and here you are going to characterize that electric field in terms of potential, which is a scalar quantity, because it will be in terms of work done. Okay, so that is the basic idea behind defining electrostatic potential, because we want to characterize the electric field in terms of a scalar quantity, which is work. Okay, now let us define electrostatic potential. So we have understood the idea behind defining this electrostatic potential. Now let us see how to define this. Okay, so because I want to characterize the field only, the electric field which is being produced by this configuration. So the work done, because we are going to define the potential in terms of work done. So the work done in moving the charge from P to Q, on which factors does it depend? And the work done in moving the charge from one point to another point, it will depend upon two factors. एक तो इस बात पर डिपेंड करेगा कि कितना चार्ज आप मूव करा रहे हो, and secondly it will depend upon the strength of electric field. So we simply want to characterize the strength of field. So anyhow I have to eliminate the dependence on the charge. So what I will do, I will consider this quantity work done upon test charge, like we did in case of electric field intensity. We simply wanted to characterize electric field. But the force, it depends upon two factors, the strength of field as well as the charge. So we divided it by the test charge only, so that the dependence of force on charge, it disappears. The same thing I am doing over here. I am dividing this work done from point P to point Q by the charge only, so that the dependence of the work done on charge, at least it disappears. Now the dependence of work done will only be upon the electric field. So this quantity, which is the work done in moving the charge from one point to another point divided by the test charge, this quantity is known as potential difference. So this is electrostatic potential difference. So this electrostatic potential difference can be written as VQP, means final potential minus initial potential. So it is equal to WPQ upon the charge. Okay. So what is this WPQ? It is the work done in moving the charge from one point to another point without acceleration. But the previous topic was electrostatic potential energy. So it was defined in the same way, that it is the work done in moving the charge from one point to another point without acceleration. So that means this term, it can be written as the change in potential energy. So it can be written as UQ minus UP, the change in potential energy, upon charge, that will be equal to the potential difference. Okay, so we have defined the potential difference in terms of work as well as in terms of change in potential energy. Now, like we did in case of potential energy difference, if I suppose that the point P is at infinity, okay, so if point P is at infinity, in that case potential energy at point P will be 0. Okay, so if potential energy is 0 and electric field is also 0, so that means potential at point P, that should also be 0. So potential at point P, it can be written to be 0 only. Point, the starting point P to be at infinity, so at infinity field will disappear, so potential can be taken to be 0. So if P is at infinity, the potential will be 0 only. So then if I use this condition in this equation, I can write in place of P, I can write infinity, so it will become VQ minus V infinity, but V infinity is 0. So this term becomes that VQ is equal to W infinity Q upon Q. So W infinity Q means what? It is the work done in moving the charge from infinity to the given point in electric field and divided by the charge which is being moved. So we can finally, the electric potential at a given point, it may be defined as the work done by external force. The work done by external force, but per unit charge in moving it from infinity to the given point, and this whole process should be without acceleration. So there are 2 points which we have to note down, that is the whole process should be without acceleration and work done should be for unit charge. So what is done? We calculate the work done for a test charge. Suppose if I take the test charge to be Q, so this work is not work done per unit charge, this is the work done upon charge Q. So when I will divide it by Q, then it becomes work done per unit charge. Okay, and by definition of potential energy, we know the potential energy at a point is the work done in moving it from infinity to that particular point. So this term is the same thing. So we can also write it as potential energy at the given point, at the point P. So potential, electric potential at a point may also be defined as, this is point P. It may also be defined as the potential energy at that point upon the test charge. Okay. Now, if we talk about its unit, so unit will be work done upon charge, so that means joule per coulomb, which is also known as volt. Now let us summarize all this part what we have done. So we wanted to define the potential to characterize the electric field, and to characterize the electric field, the scalar quantity which we are using, that is the work done. But this work done in moving the charge from one point to another, it was depending upon two factors: the strength of field as well as the amount of charge which is being moved. So because we wanted to characterize the field only, we have to eliminate the dependence upon charge. So we have divided the work done by the charge which is being moved. So this ratio, the work done upon charge, it is known as electric potential difference. I want to write one more mathematical form in terms of force. See, this is the work done, and we know the work done is force into displacement. Yes. So this is the external force. As I told you, the work done we will be calculating for the external force only, and because the charge is being moved away from infinity to point P and upon this charge. So this is one more form of potential. And because the known force to us will be the electrostatic force, and because we are doing the whole process without acceleration, so both the forces should be equal in magnitude. So that means in place of external force I can place the electrostatic force as well, but because their direction is opposite, so sign of work will change. So that means I can write it as the work done by electrostatic force with a negative sign, and we are moving it from infinity to point P and divided by this charge. So these are some other forms of potential. So finally the summary is that the potential energy difference between 2 points P and R, that is defined as the work done in moving the charge from point P to point R, and this is without acceleration. And if we define the potential difference, then the change will be in terms of charge. So again we have to calculate the work done in moving the charge from point P to point R, but now we have to consider the work done per unit charge. So that is the basic difference between these two quantities. When we talk about potential energy, we consider the whole charge which is being moved, and while we consider the potential or potential difference, then we have to calculate work done per unit charge. So that is why we have to divide the work done by the charge. So we get a relation between potential difference and potential energy difference, and the relation is that potential difference will be equal to potential energy difference divided by charge from here. Now in the same way, if we calculate the potential energy at a point, so potential energy at a point will be the work done in moving the charge from infinity to the point. So infinity is taken as the reference. So it is the work done in moving the charge from infinity to point P without acceleration. And if we calculate the potential at a point, then again we have to move the charge from infinity, but again we have to calculate the work done per unit charge. So at last we will divide the work done by the charge. So we get the work done per unit charge, which is the potential at the point. So relation between potential at point and potential energy at a point will be type of similar relation.